Okay. There are a total of 10 networks for the above topology. R1, R2 serial, this IPv4 and this IPv6. Okay, and okay. R2 and R3, this IPv4 and this IPv6 subnet. Okay. VLAN 21 students, this VLAN, VLAN 23 faculty, this. These are the subnets, 21 and 23. R3, loopback 4, 5, 6, and 7. 4, 5, and 6, IPv4, 7, IPv6. VLAN 99 management. R2 loopback 0, this IPv4 subnet. R2 gigabit 00, this IPv4 and IPv6 subnet. Erase any startup configuration, erase any VLAN configuration, and reload devices. Okay, for example, on R1, now enable erase startup config. Enter and reload the device. Do this on all routers, R1, R2, and R3. For example, on switch, enable erase startup config, enter, and also delete the VLAN that file, that is file for the VLANs, delete VLAN that enter, enter, enter. Okay, reload. Do this in all switches S1 and S3. Okay, complete basic configuration for each of the routers and switches according the information in the following table. Disable DNS lookup, device name, encrypted privilege exit password, console access password, telnet access password, encrypt the plaintext passwords message of the day banner. For now, I will only configure the host name, the device name. Okay, I will do this later. I will only configure the device name because passwords will interrupt my configurations. Okay, I will do this later, but I will okay, disable DNS lookup, no IP domain lookup, device name. Okay, now I will configure the device name, but the next command is encrypted privilege exit password. Enable secret for encrypted and class. Console access passwords, online console 0, the password Cisco, but login to enable the password. Internet access password also Cisco, line BTY 0 to 15, password Cisco, login to enable the telnet password, and encrypt the plaintext passwords and use this service password encryption. Finally, configure a banner message of the day with the message unauthorized access is prohibited. Banner message of the day, unauthorized access is prohibited. Okay, okay, I will apply this later. Okay, for now only I will configure the device name and now configure these IP addresses. Okay, use this table, but I have the subnets on the topology. Okay, loopback 7 says network C on IPv6, but in this table says network 3 on IPv6. Okay, I will use any of those networks, but I prefer to use 3 here. 3. Okay, ready. The VLAN. Okay, configure all addressing. Start with R1. Now enable configure terminal hostname R1. Subinterface 21, 23, 99. On gigabit 01, this interface gigabit 01. Interface gigabit 01. That 21 for VLAN 21 students. The description will be students is optional. The encapsulation should be .1q and belongs to VLAN 29, the 21. And the IP address is this. This VLAN. Use the fields usable in all cases. Okay. The fields and subnet mask 24. VLAN 23. description, faculty, 23, fields IP, management is 99, description, encapsulation, IP address 99.1, the fields, and enter to physical interface gigabit 01 and enable shutdown, no shutdown. Ready. Okay, it's green now. The LED. Configure serial 0. Serial 0 has the clock rate. The clock rate this IP, the fields on IPv4, the fields on IPv6 on this subnet. Interface here 000. Clock rate. The IP address. The fields. Subnet mask for 0D. IPv6 address. The fields. The fields IP. Okay, no shutdown. Okay, on R2. But finally on R1 exit, don't forget to enable IPv6 Unicast routing to permit the routing in IPv6. Okay, R2. Now enable configure terminal hostname R2. Okay, serial 0. IP address. Remember the subnet, the connection to R1. If R1 is the first IP, this will be the second. IPv6 address. The second, prefix 64. No shutdown. Serial 1. Serial 1. Use the second usable IPv4 and IPv6 address. Okay, on this subnet. IPv4 223. The second subnet mask theory. IPv6 subnet number 2, the second IP, and uses the clock rate. No shutdown. Gigabit 00, the connection to internet server, this interface, gigabit 00, okay. The first usable IPv4 and IPv6 addresses on this subnet. gigabit 00. The IPv4 address, if 28 is the subnet, the first is 29. And the subnet mask for 29 is 248. The IPv6 address, subnet A, just the first, prefix 64, no shutdown. Exit, don't forget to enable IPv6 unicast routing. Don't forget the loopback 0 on R2. Specification is indicated. Okay, the IP is 100 because the subnet mask is 32. Interface loopback 0, IP address, subnet mask 32. Okay, already enabled up. Configure R3 and serial 1 first usable IPv4 and IPv6 address in this subnet. Serial 1. This interface. No, enable configure terminal hostname R3. Okay, and serial 1 interface, serial 001, IP address 124.223. First IP, subnet mask 30. An IPv6 address, the number 2, first IP, prefix 64. No shutdown. Configure loopback interfaces and use the first usable IPv4 and IPv6 addresses. Okay, interface loopback 4, IP address 172.45.4.1 because the first, and subnet mask 24. 5 6 and 7, the IPv6 address 3 column 1 prefix 64. Okay, automatically enabled. Exit, enable IPv6 unicast routing. Now, all addressing on routers is done. Configure on switch 1 on VLAN 99 the addressing. Okay, switch 1 and switch 3. Okay, switch 1. Enable configure terminal hostname S1 interface VLAN 99. Okay, it says VLAN 99. This IP 99 172.45.99.11. Subnet mask 24. Shut down and don't forget to configure the default gateway IP default gateway because the default gateway permits the connection to other networks and internet. The default gateway for subnet 99 is 1. The subinterface placed on gigabit 01 on R1. Okay, the same configuration on S3. Enable configure terminal hostname S3 interface belong 99 IP address 172.45.99 subnet mask 24 no shutdown exit IP default gateway. Okay, 45.99.1. Finally, internet PC on the interface. Okay, the second usable because router has the first. Remember, see if 28 is the subnet. If 28 is the subnet, 29 129 the first, 130 the second. One 29 is 248. The default gateway is the router. So the router is 129, the first IP. Okay, this is the default gateway for the server, gigabit 00 on R2. And don't forget the IPv6. The second prefix 64. The default gateway is the IP address on the router that is the first IP. Okay, gigabit 01, activate interface, subinterfaces, serial. Don't forget to enable IPv6 routing on routers. Okay, IPv6 router on all the routers. Switch 1. Okay, don't forget to configure the default gateway on S1 and S3. Okay, it should be S3, and on internet server or internet PC, the default gateway on IPv4, default gateway on IPv6. All this already. Now configure routing. Okay, on R1 first we'll configure a default IPv4 route. Use the interface serial 000 as exit interface. Okay, go to R1. Enable configure terminal IP route. Default route 1234 1224 serial 00 as the exit interface. This interface, okay, to reach internet and other networks. IPv6 default route, also using serial interface. Okay. IPv6 routes. This is the default route on IPv6. Configure RIP version 2. Router RIP version 2, no auto summary. Advertise directly connected networks. First of all, show the directly connected networks. Do show IP route connected network connected. All these, the directly connected networks. Advertise all this. Network. Okay. Network. Finally, the management 99. Set all LAN interfaces as passive. Okay. All these LAN interfaces passive. Passive interface. That 01.21.23.99. Okay, gigabit 01, gigabit 01. Disable automatic summarization. Okay, this is the command to disable automatic summarization. R2, enable configure terminal. Configure a default IPv4 route. Use the Internet PC IPv4 address. Okay, IP route, the default route, the next hop IP address for the Internet PC. Remember, 128 is the subnet, 129 the router, and 130 the server. Okay, so configure 130. 130. Okay. Now on IPv6 route, the default route, use the Internet PC's IPv6 address. This is the IPv6 address for Internet PC. Configure RIP2 router RIP version 2, no auto summary. Advertise directly connected networks, all IPv4 networks except gigabit 00. Okay, do show IP route connected to show the directly connected networks. All these three directly connected networks, but do not include gigabit 00 because it's the connection to internet, and we'll use our default static routes. Okay, 223. And 168.0.100. Okay, 168. Set all LAN interfaces as passive. Set all loopback interfaces as passive. All loopback en LAN. Passive interface, loopback 0. The LAN interface. This is the connection to internet because it's not used on RIP, because it's not advertised on RIP. So you can configure as passive. Disable automatic summarization. This command R3, the same process. Okay, but now the enable configure term. The exit interface for R3 is serial 001. Configure an IPv4 route, default IPv4 route, and a default IPv6 route. In both cases, the serial 001 is the exit interface. This is for IPv4, the exit interface, and this is for IPv6. RIP, router RIP version 2, no auto summary. Advertise directly connected networks, do show IP route connected. Okay, all this Disable automatic summarization. Okay, this is the command. And set all lang interfaces as passive. Set all loopback interfaces as passive. Okay, all loopback interfaces as passive. Passive interface loopback 4 interface loopback 4, 5, and 6. Okay, loopback 7 is not included because loopback 7 uses IPv6. Okay, on switch S1, create the VLAN database, enable configure terminal, use the information provided by IP addressing scheme table. Okay, create VLAN 21, 23, and 99. VLAN 21, the name students, 23, name faculty, 99, name enter, name management. Okay. Force trunking on interface fast Ethernet 3, VLAN 1 as the native VLAN. Okay. And force trunking on interface fast Ethernet 5, VLAN 1 as the native VLAN. Okay, on 3 and 5 trunking, because this is a connection to a router in a connection between switches, fast Ethernet 3 and 5. Okay, interface range fast Ethernet 3, comma fast Ethernet 5. Switch port mode trunk. Okay, enter. Okay, switch port mode trunk, and also switch port trunk native VLAN 1. Enter. This command is not necessary because by default the trunk interfaces uses VLAN 1 as the native VLAN, but this is the command. Configure all other ports as an access ports. Use interface range command. Okay, all except 5 and 3 are access ports. Exit interface range from 1 to from 4 from 5 from 6 to 24 and gigabit 0, 1 and 02. 0, 1 and 02. Okay, all except 3 and 5. Remember, switch 2960 uses fast Ethernet from 1 to 24 and gigabit 1 and 2. Gigabit 0, 1 and 02, all except 3 and 5. Switch port mode access. Okay, assign 6 to VLAN 21. This interface should be assigned to VLAN 21. Okay. Interface fast Ethernet 6. Switch port access VLAN 21. Shut down all unused ports. Okay, the unused ports are all except 3, 5, and 6. Interface range 1, 2, 4, and from 7 to 24. The unused ports are all except 3, 5, and 6. Shut down. The same process on S3. Create first of all the VLAN database. Okay, use this table. Enable configure terminal VLAN 21 name students 23 name faculty 99 name enter name management. Okay, exit. Force trunking on Fast Ethernet 3. This interface should be trunking to connect as one. Interface Fast Ethernet 3. Switch port mode trunk. VLAN 1 native VLAN. Switch port trunk native VLAN 1. Configure all other ports as access ports. Okay, all except 3. Exit interface range, Fast Ethernet 1, 2, and from 4 to 24, and gigabit 0, 1, and 2. All except 3. Switch port mode access. 18 to VLAN 23. This 18 to VLAN 23. Okay. Interface 18. Switch port access VLAN 23. Shut down all unused ports. Shut down all except 3 and 18. Exit. Interface range 1, 2, 4 to 17, and from 19 to 24. All except 3 and 18. Shut down. Okay, configure the Dhcp and NAT. Reserve IP addresses for static configurations. For both VLAN 21 and 23, reserve the first 20 IPv4 addresses from 1 to 20. Remember, this is the subnet for VLAN 21 and this is the subnet for VLAN 23. Configure the Dhcp, but first of all exclude the first 20 IP addresses on each VLAN. The server is R1. Configure terminal. Oh, okay, enable Ctrl+Shift+6. Enable configure terminal. Exclude IP DHCP. Excluded address. 172.45.21 for VLAN 21. The first from the first to the 20. Also for VLAN 23. From 23.1 to 23.20. Now create the pools. IP DHCP pool VLAN 21. Okay, but the name should be students. Okay, create a DHCP pool for VLAN 21 name students. Okay, do not use this, use students. Okay, the DNS server is 10.10.10.10. Domain name, use this. Set the default gateway. First of all, the network is the subnet 21.0 subnet mask 24. The network is the subnet. The default router is the first IP configured on the router because this will be the default gateway. The first IP, the default gateway, and DNS server Okay. Also use this domain name CCNA SA net. Domain. Mark question to. This is the command. Okay. Domain name CCNA SA.net. Okay. The same process for Dhcp pool on VLAN 23. But the name is faculty. Use the same DNS, the same domain name, and use the default gateway. The IP DHCP pool faculty. The network is 23.0, the subnet, 24 subnet mask. The default router is 23.1, the DNS server is 10.10.10.10, same domain name. And ready. Okay, on R2, create local database with one user account. Okay, create this user on R2. Enable configure terminal. Username. Web user. Privilege 15. And the password is Cisco 12345. Enable HTTP server, IP HTTP server. Okay. Okay, Packet Tracer does not support this command because the server cannot be enabled on Packet Tracer, but this will work on GNS3, VIRL, or Real App. Configure the HTTP server to use the local database for authentication. IP HTTP authentication local. Okay, also Packet Tracer does not support this command, the local authentication. Okay, create a static NAT to the web server. The web server is located on loopback 0 interface. Okay, the web server will be the loopback 0 interface and create NAT. Use a static NAT for this, and the global IP is this 200.200.200.131. Okay, the IP NAT inside source static. The local IP is this loopback 0 192.168.0.100, and the global IP is this 200.200.200. 131. Assign the inside and outside interfaces is required for NAT. Gigabit 00, the outside interface, and loopback 0, the inside interface. IP NAT outside, loopback 0, IP NAT inside. Configure dynamic NAT inside private access list. Use a standard access list number 1. Okay. Exit IP access list number 1. Write 3 ACL statements, allow the student network to be translated and faculty network to be translated. Okay, these two subnets, 21 and 23, will be permitted for this ACL. permit 172 4521 0 and use the wildcard mask to 24, the 23 for faculty, and allow the IPv4 loopback networks on R3 to be translated. Okay, just these three loopback on R3. Okay, but you need three statements for these three, but should be included only in one statement and summarize all these three subnets 4, 5, and 6. Okay, on R2, 4, and the wildcard. Okay, the summarization for these three subnetworks is 4.022. Okay, 4.022, 4.0, but the wildcard for 22 is 3 to 55. Okay. Okay, this subnet will include 4.0, 5.0, and 6.0. But the summarization has a different subnet mask, and this is the wildcard for that subnet mask. Enter. Define a pool of usable public IP addresses, the pool name internet. IPNet pool, the name is internet. Pool of addresses to include, use this range from 132 to 134. (132 to 134). And the subnet mask is 248. Okay, ready. Define the dynamic NAT translation. IPNAT inside source list. The list is the access list number 1. And the pool is the pool called internet. This. Okay, enter. Don't forget to include the serial 00 and serial 001 as IP NAT inside interfaces for NAT. Interface 000 IP NAT inside, serial 001 IP NAT inside. Okay. Okay, test from R1 pings to R2 serial 000 IPv4 and IPv6. Okay, enable ping. The R2 has the second success. 1 the second success. From R2 ping R3 serial 01 on IPv4 and IPv6. R2 and ping And that one, the first IP placed on R3. Success. 2 in the first. Success. Internet PC ping the default gateway on IPv4 and IPv6. ipconfig. This is the default gateway. Success. Success and ping to the default gateway on IPv6 A.1. A column 1. Success. Control ready. Switch 1 VLAN 99 IPv4 address on R1. From switch 1 to R1 VLAN 99. Okay, enable ping 72.45.99.1. This is the IP configured on R1 on VLAN 99. Success. From S1 to VLAN 21 IPv4 address on R1. Okay, on R1 is 21.1. From S3 ping R1 VLAN 99. Enable ping. .1, the IP on router R1. Success. VLAN 23 IPv4 on R1. 23.1 on R1. Success. PCA ipconfig. Okay. PCA should uses the DHCP. Okay, and ipconfig. Okay, very well configured. From PCC also configure on DHCP. Success. From PCC ping PCA. Okay. This is PCA. If you exclude it from 1 to 20, the next is 21, 21.21. From PCC ping to PCA. Success. From Internet PC, enter the web browser. On this interface, 131. Okay, Packet Tracer does not support this feature because the HTTP server cannot be enabled on R2 because Packet Tracer does not support the HTTP server on routers. So this will not work. Okay, but you can use ping to verify from a ping from internet server to this IP 200, 200, 200, 131 to verify that static NAT is working very well. Okay. Success. Okay, remember static NAT translate this loopback interface to a public IP address. Configure R2 as NTP master. Configure terminal. NTP master stratum level 5 and R1 NTP client. The server will be R2, the master. R1 configure terminal NTP server. The IPv4 address on R2 serial 00 is this subnet with the second interface. Okay, 10, 184, 122, the second on R2. Configure R1 to periodical calendar updates with NTP time. NTP update calendar. Restrict access to VTY lines on R2 according to the following specifications. Okay, before to do that, apply the basic configurations. No IP domain lookup, enable secret class, line console 0, password Cisco login, light VTY 0 to 15, password Cisco login. This is for telnet. Service password encryption to hide the plain text passwords. And the banner. Apply all this on all devices. Remember, I already configured all host names on all devices. R1 paste, R2 paste. Remember, global configuration mode. R3 enable configure terminal paste. S1 configure terminal to access global configuration mode, paste. S3 configure terminal, paste. Ready. Now configure a named access list to allow only R1 to telnet to R2. Okay. R2 named access list IP access list, and this should be a standard, and the name is admin management MGD. Use R1 and R2 serial IPv4 addresses. Apply the named access list to the VTY lines. Allow only 10 telnet logins on the VTY lines. Disable SSH. Okay, permit host only R1. Use the serial interface. This IP for serial interface 000 is this subnet. The first IP is configured on R1. Okay, so the host is 10, 184, 122, 1. Permit only serial interface on R1. Okay, and apply to VTY lines from 0 to 15. Exit line VTY 0 to 15. Access class. Use this name. Okay, admin mgd -mgd in incoming traffic, and allow telnet logins on the VTY lines. Transport input telnet. Okay, transport. Okay, ready. Only telnet. Okay, from R1 ping internet PCs, IPv4 address, and ping this IP. The internet server is, this is the subnet, but internet server is 130. Cisco enable class ping internet IPv4 internet server. Use this. Success. Okay, also you can ping from PCA to internet server. Ping. Success. From PCC to internet server. Success. From R1 telnet to R2 serial 00 interface IPv4 address. From R1 telnet 10.184.122. R2 has the second IP password Cisco enable class. Now you are connected to R2 from R1. Okay, success, exit. From R3 telnet serial 001 should fail. Okay, telnet to R2 Cisco enable class telnet. Okay, to this interface serial 001 on R2 223 the second refuse it. Okay, it should fail. From internet PC gigabit 00 should fail. Telnet the 129 is gigabit 00 on R2. Refuse it. Internet PC ping PCA should fail. 172.45.21 .21. Success, but should fail. From PCC, from internet PC ping to PCC IPv4 address to this IP 23.21 23.21. Okay, in both cases the replay is not from the 21, is not from the PCA. In both cases the replay is from this IP 200.200.200.133. Also the another ping 200.200.200.133. Okay, go to R2 Cisco enable class show running config. Okay, look at this range 200 to 200 132 to 134. So the NAT is permitting this ping. Internet server, go to the default gateway that is R2, and R2 show running config. Show IP route. R2 knows the destination subnet, and the destination subnet is here, 21.0 or 23.0. Okay, and the replay goes from PCA to internet server, but using NAT. Okay, so this ping will be successful. From internet PC, ping PCA should be successful, and from internet PC to PCC should be successful. Okay. Okay, what command displays RIP process ID, routing networks, and passive interfaces and configured routers? For example, on R1, Cisco enable class show IP protocols. Okay, the routing protocol RIP. Okay, process ID for OSPF or router ID for OSPF or EIGRP. The routing networks, this passive interfaces configured on this router. What command displays only RIP routes? Show IP route RIP. Only RIP. R for RIP. RIP section of the running configuration. Show running config pipe section router RIP. Okay, Pocket Tracer does not support the pipe, but will show this section. This section displays the matches and access list. Okay, this can be show on R2 show access list. Okay, add 8 matches for this or show IP access list. Okay, what command resets access list counters? Clear IP access list, enter. Okay, clear IP access list counters. Okay, Pocket Tracer does not support this command. Clear IP mark question. Mark question. Okay, do not use IP clear access list counters. Okay, success, and verify using show IP access list. No matches counters. Displays ACL is applied to an interface, and the direction that is applied show IP interface. Okay. Okay, for example, on loopback 0, you can see the outgoing access list or inbound access list, but there are no access lists configured on interfaces, only on NAT and only on BTY line. What command displays the NAT translations? Show IP NAT translations. Okay, the static but you can ping from PCA to internet server and you will see the NAT translation. Okay. And what command is it to clear dynamic NAT translations? Clear IP NAT translations. Clear IP NAT translations. Translation. And use this. Okay, success. Verify. Show IP NAT translations. Only the static. All dynamic, erase it. Okay. Thank you very much.